Welcome to National 5 Maths Practice Paper A. This is Paper 1, so no calculator allowed. Question 1. This is a subtraction of fractions. Whenever you see fractions like this, where we have mixed numbers, 3 and 2/5, first thing I would always do is to convert this, okay? So 3 and 2/5, I'm going to write 3 and 2/5 as 5 at the bottom. Remember, 3 times 5 is 15, and then add on the 2 at the top, okay? 17/5. I'm also going to do the same with the 1 3/4 as well. So I'm going to put it into quarters, same number at the bottom. 1 times 4 is 4. You don't need to show you're working for this, okay? You can do this in your head. I'm putting wee multiplications and pluses. You don't have to do that. You convert it in your head. 1 times 4 is 4. Add the 3 at the top is 7. Okay, so I'm going to write it then as 17/5 take away 7/4. Okay, because I've basically just converted them. Right, if it's an addition or a subtraction of fractions question, you must have a common denominator. So a number that 4 and 5 both go into. 20 can be divided by 4 and 5. Now, because we've changed the bottoms of the fractions, we must also multiply the top of the fractions as well. So it was a 5, now it's a 20. So this side has been multiplied by 4. So that 17 at the top also has to get multiplied by 4. Remember, it's a non-calculator question. 4 17s, you're allowed to do a wee sum at the side. Okay, 4 10s, 4 7s, 68. The 4 on the bottom of the other fraction has been multiplied by 5, therefore, to make it 20. So the 7 at the top also has to get multiplied by 5. 7 5s, 35. And when we have the common denominator, it makes it nice and easy question now. It's really just 68 take away 35, which is 33. That is perfectly fine to leave it like that, okay? You don't have to, but if you want to go on and simplify it as mixed numbers, how many 20s are in 33? 1 and 13/20. So either answer is perfectly fine, okay? Question 2, factorise. So only asking you to factorise, okay? Factorise. Anytime you're asked to factorise, look for a common factor. There's 3 main methods. It's not a common factor, okay? It should be obvious. This is one of the trinomials. X times x to get the x squared. We're looking for 2 numbers that multiply to give us negative 15. 2 numbers that multiply to give us negative 15. Negative 3 and positive 5, or positive 3 and minus 5. The numbers need to add up. I always tend to put that at the top. The numbers need to add up to positive 2. Which pair of numbers will add up to positive 2? It's going to be this one here. The other pair of numbers add up to negative 2. So x minus 3, x plus 5. And that is that question done. Okay, if it had said solve, you would take each of the brackets and set them equal to 0, but it doesn't say solve, so that's us. Number 3, find the equation of the straight line. Right, equation of the straight line, if you've got a diagram, we should simply be able to do y equals mx plus c. The c is the y-intercept, remember? I can see the y-intercept, here's the y-axis here. The y-intercept is 5, so c is 5. I can also work out the gradient. The gradient from a diagram should be pretty simple. I shouldn't need to use the gradient formula here. The gradient from a diagram, we should be able to use a triangle. Let's have a wee look, see if I can find a nice wee neat triangle. Oh, that's not too bad. Right, for that triangle, the vertical over horizontal, remember the gradient is the vertical over the horizontal. It's a positive sloping line, so it's a positive number. The horizontal is easier to work out. Across the bottom here is, remember, don't just count boxes, look at the numbers, 0, 1, 2 on the x-axis. So the horizontal is 2. The vertical, be very careful, that's 5 there. And that in there would be, that's 25, isn't it? Because it's between 20 and 30. So the vertical distance there is actually 20. So it's 20/2. So the gradient is actually 10. So the question says, write the equation of the line. That was a 10, wasn't it? The equation of the line, y equals mx plus 3, y equals 10x plus 5. Okay? Number 4. Express this in the form x plus a bracket squared and find the coordinates of the turning point. Right, we'll do the first part. This is what we called, and again, don't worry if you don't remember the names of what it's called, okay? This is a completing the square question. So it's, oh, I'm using the red pen, that's fine. So completing the square. Half it, square it, subtract it. It needs to look like this, okay? The number that we put in the bracket is half of this. So that's why it's x plus 4 in the bracket squared, not x plus 4x. Okay, you won't get the mark x plus 4 in the bracket squared. Half it, so that's what we've done. Now you square the 4. Half it, square it, subtract it. Square the 4. 4 squared is 16. What do you do with the 16? We subtract the 16. We're not finished, however. Don't forget this. Minus 7 at the end. The actual answer, and some people can actually do this in their head, right? The minus 16 and the minus 7, put it together. Take away 23. That is the final answer. You get a mark for the x plus 4 squared, and you get a mark for the minus 23 at the end. We're not quite finished because it did also say find the coordinates of the turning point. If we were to make a wee sketch of this, right, I'll do a sketch, it's not asking for it, but if we were to draw a graph of this, we would go, it's going to be one of these graphs, okay? We would go to, this here indicates negative 4, so I'd put negative 4 on it, and this here indicates negative 23. So negative 4 on the x-axis and negative 23 on the y-axis. The turning point is basically negative 4, negative 23. And you can see that from the numbers in the equation. No graph was needed there, okay? That was me just showing you where the points come from and how it links in to the diagram. You could be asked to do a sketch. Right, number 5. Change the subject of the formula to the letter R. Right, the letter R is on the right-hand side. First thing I'm going to do is switch it all around, okay? And remember, if you switch it all around, you are not changing any signs at all. You only change signs if you move one piece from one side to the other. When you switch it all around, we're not changing any signs. Right, let's see. Oh, we'll stick to the red pen. Letter P. So we want to keep the R. First thing we're going to move is the minus 5. Where's it going? It's moving across. So I'm going to leave it with R cubed B is equal to, what's going to happen with the take away 5? We add it to the other side. Right, what's going next? We've got a cubed and we've got a letter B. We keep the R cubed. The B is moving across first. What is the B doing to the R cubed? It's multiplied by the R cubed. They're multiplying each other. So we're going to divide by the letter B. Okay, this is what R cubed is. We need to find out what R on its own is. If we know what R cubed is, we can find R on its own by doing the reverse of cubed, which is the cube root. To draw the, what I've drawn there is just a square root, but because it's a cube root, we put a wee 3 in there. Okay, if it was a square, R squared was equal to, the cube root, we would just do the tick sign for the square root. You don't need to put a wee number 2 in. Okay? And just check these notifications that have come up. Right, next one. Number 6. Two vectors are defined. The letter U and letter V, two vectors. Find the resultant vector U plus 3V. I'm going to go back to the black pen, I prefer it. Right, we'll do part A first. It's U plus 3V. What we're doing therefore is 2 negative 5, and we're going to add on 3 V's. So it's 3 of them. Okay? You could have went on straight on the first line, and I know some people would have probably multiplied the vector by 3 straight away. That's fine. If you had started by doing 3 negative 4s is negative 12, and 3 3s is 9. That would have been perfectly fine. The first line there is not actually needed. Right, so vector v, we've multiplied it by 3, and we're going to add on vector u. 2 add negative 12, 2 take away 12, is negative 10. And negative 5 add 9, remember this is all non-calculator, is 4. So that's the vector we're looking for. Part B. Oh, I don't know if I'm going to have space. I'll have to squeeze it in somehow. Part B. Might be able to do it here. Remember, what they're asking for there is the magnitude of the vector. The magnitude of the vector, quite often it could be a 2-component vector or it could be 3 components. The magnitude, it's tied into Pythagoras. It's based on Pythagoras, okay? So the magnitude of this one that we've just worked out, the negative 10, 4, what we do is we square the negative 10 and we square the 4. And we add them together. Oops, that doesn't look like a square. Oh, jeez. That's a bit better. Square them both, add them up, and take the square root. So really what we're doing here is squaring the 10, or squaring the minus 10. Square the 4. 4 squared is 16. It's the square root of 116. Now, remember, sometimes when you get a paper, if you know the answer to the square root of 116, or if it was one that would simplify, it's absolutely fine. If you don't know the square root of it, then that's absolutely fine. It's just saying find the magnitude. It's not saying simplify. Okay, it doesn't mention anything about simplify. However, I will actually simplify this one for you. Okay. Quite often, if you get a vector question like this where they're asking for the magnitude, it will quite often ask you to simplify the surd, so I'm going to simplify it. Right, square root 116, I'm going to simplify it. Two numbers that multiplied to 116, one's a perfect square. Which number? Think of your square numbers. 4 actually does go into 116. I can write that as root 4 root. How many 4s make 116? Well, 4 25s make 100, and 4 4s make 16. So it's the square root 29. 4 29s. Wait a minute, darling. No, not just now. Square root of 4. Root 4 is 2. 2 root 29. And I close the door. Oh. Number 7. Part of the graph is y equals cos bx. Find the value of b. The letter b, remember, is to do with the period of the graph. It's to do with how many cycles of this graph there is here, okay? Not necessarily one cos graph, okay? One cos graph generally looks like that, and it ends at 360. So this number for letter B is basically how many cos graphs are in 360. So this cos graph ends at 120. Cos graph ends at 120. How many would there be in 360? Sorry about the interruption, they've totally put me off. Right. You could probably work out, some of you have probably worked out the answer already. No sketches are needed for this. I am just showing you where this number comes from. The answer is 3, okay? What you have is a diagram that ends at 120, but the value of b is how many would there be in 360? Well, if each one is 120, you would actually get 3 in 360. So that's why b is actually 3. No graphs or anything is needed here, okay? A simple b is 3 is the answer, okay? Right. Number 8, find the point of intersection of these lines. The point of intersection can be done by 2 equations. I'm going to write them one above the other. And in doing so, I'm hoping that you know how we're going to do this. 2 equations, one above the other, is simultaneous equations. Simultaneous equations can find the point of intersection of 2 lines. So, I'm going to take the y's up to the same number. One's negative 3 and the other one is a positive 1y, just one on its own. I'm going to take them up to the number 3. So I'm going to times the top equation by 3. I'm going to leave the bottom equation as it is because it'll be negative 3. Positive 3, negative 3, the whole point is they'll cancel out. So I'm going to times the first full equation by 3. Okay, second equation is staying as it is. And remember, by doing so, we can add the equations together and the y's will cancel out. Okay, x's 7x equals 21 by adding the 6 and 15. That indicates this is working because 7 does go into 21, x is 3. Okay, if that was 21 and you were doing 5x equals 21, I'd be thinking, something's not quite right, go back. I'm not saying they're always whole numbers, but most times they are. This is not finished, however. We need to go back in and sub in x equals 3 to find y. Take the easier equation. In fact, I would always suggest take the equation that doesn't have a subtract in it. I'm going to take this equation here. If you choose an equation that has a subtract or a negative in it, you basically increase your chance of making a wee mistake. Okay, it's a wee bit more difficult to deal with negative numbers. So x is 3. 2 3's. Add y is equal to 5. 2 3's, so 6 add y equals 5. How do you find y? Well, you do 5, and where does the 6 go? Across here, and what happens? You take away 6. So y is actually negative 1. The question says, find the point of intersection. It's a point we need to write down. Put your x number first in the bracket, and then the y. You don't need to indicate x and y at the top like I've done here. Just put your x first and then put your y next. So it's 3 negative 1. Right, a parabola has this equation. Use a discriminant and determine the nature of the roots. Right, discriminant. Part of the quadratic formula. This is a discriminant, b squared minus 4ac. If you're ever asked anything about the nature of the roots, that is what you use. A, b and c. A is the number or the coefficient of x squared. We've got 1x squared. B is negative 3 and c is 7. Sub these numbers in the right place in the formula. 4 times 1 times 7. Negative 3 squared. 3 squared is 9, positive 9. Take away 4 times 1 times 7. 4 7's 28. So we've got negative 19. Okay? Now the question says you determine the nature of the roots. We need to write, we're not allowed to write, do not just write no real roots here. Okay? The reason there's no real roots, it's because b squared minus 4ac is less than 0. Therefore, there are no real roots. My writing's messy on this, it's difficult. That's it. Number 10. A straight line has this equation. A second line is parallel to this, and it passes through this point. What is the equation of the second line? Right, it's parallel to this. Remember, if you get two lines that are parallel, they are sloping in the same direction. So parallel, they've got the same gradient. Okay, so this line that we have to work out, the line that we have to work out has got the same gradient as this. How do we find the gradient of that line? Well, that isn't the normal equation of a line, the way it normally looks. The equation of a line normally says y equals. There's a couple of different ways we can rearrange the equation, but we want to rearrange that equation to just say y equals. There's a nice wee simple thing we can do. This says negative y. Okay, I'm going to move the negative y across, and it will say 3x equals 9 plus y. So remember, we want to change it to y equals mx plus c. That is the normal equation, and then if we know it's y equals mx plus c, m is the gradient. It doesn't quite say mx plus c. Y equals, I'm going to move the 9 back now. There we go. So basically, y is equal to 3x minus 9. What is the gradient then? the gradient is 3. So the question says, find the equation of the second line. The second line is parallel to that one, so the gradient is 3. So the gradient of this new line is also 3. So the question says, find the equation of the line. We've got the gradient and we've got a point. Now this is actually tied into quite a it's a common first higher question on the straight line. Right, y minus b equals m bracket x minus a. Okay, that's the equation of a line. That can work out the equation of a line if you know a point and the gradient. This is your a and this is your b. So y minus 3 is equal to 3 bracket x minus 5. Tidy that up a wee bit. Y plus 3 is equal to, that's a 3 there, sorry, 3x minus 15. We don't really like to leave it like that. We'll write it as 3x plus 15, and I'm going to bring the 3 across. So the actual answer is y equals 3x plus 12, because you've got a plus 15 and a minus 3. Right. Number 11. Here's a parabola. What's the coordinates of the minimum turning point? The minimum turning point come from these here. Okay, see that minus 2? It means that the minimum turning point is 2 along. That's what that means. See that minus 9 at the end of this equation? It means the minimum turning point is down at minus 9. So what's the coordinates of the minimum turning point? It's simply positive 2 minus 9. What's the coordinates of point C? Point C on this diagram. Point C is where it crosses the y-axis. I wish I'd gave myself a wee bit more room to do this. How do you find out where something crosses the y-axis? What do? You sub in x equals 0. If the question said where does it cross the x-axis, you sub in y equals 0. We're going to sub in x is equal to 0 into what? Into the equation. We're going to sub in x is 0. 0, take away 2, bracket squared, take away 9. 0 take away 2 is a negative 2. We're going to square it and take away 9. So it's 4 take away 9, which is negative 5. However, we're looking for the coordinates of point C. What is the x value again? It was 0 that was subbed in, and the y value is negative 5. Okay? I'm just going to do that so that you know that that's actually the answer for part B and you don't get mixed up. Part C, it says A is the point negative 1, 0. That means A is negative 1 on the x-axis. What is the coordinates of B? Right, remember these graphs are symmetrical, okay? So if that was 5 across that way, this would be 5 across this way. Okay, I'm going to use a different coloured pen here. What's the distance between here and here? Remember the number 2 on the x-axis was from the turning point from the equation. So that length is 3 because point A is negative 1 on the x-axis and the centre point is 2. So add on another 3. How many along would point B be? It'd be 5 along the x-axis. So point B is simply 5 across. Is it anything up or down on the y-axis? No, so it's 5, 0. Right. This is the last question, okay, which is why the videos may be quite long, I think. The square and the rectangle shown have the same perimeter. Show the length of the rectangle is 3x plus 1. Right, it's a square and that's a rectangle. They've got the same perimeter. Right, let's work out the perimeter. We know this length is 2x plus 2 as well, because remember a square has 4 sides the same. So what's the perimeter of the square then? Remember, the perimeter is the total length of all the distances of the shape, added up together. Add up the 4 sides. So basically you've got a 2x plus 2, a 2x plus 2, another 2x plus 2, and another 2x plus 2. You've got 4 2x plus 2s. Right. or just add up 2x, 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 2x. You've got 8x plus 8. That's the total perimeter of that shape. Okay? Now, it tells us the perimeter of the rectangle is the same. Right? Okay? The rectangle. Right? There's a couple of different ways you could do this. It says show that the length of the rectangle is the same. Right, well the length of the rectangle, oh right, it says show that, right, okay, it's not actually asking you to work it out, it says show that it's this, okay. Right, if it was 3x plus 1, and if that was 3x plus 1, and that was 3, it says show that it's 3x plus 1, okay. Basically, you can do, well, add them all up. Now, if we add up all 4 sides, what should we get? Well, they're telling us the perimeters are the same. 3x, 3x, x and x, 8x. Oops. 1, 1, 3 and 3. There we go. So we basically worked out the 2 perimeters and they're both the same. There's another way you could have worked out. 3x plus 1 is the length, as it adds up to the same perimeter. Okay, I'm going to stop there and I'll give you questions to try. Okay, best of luck. Let me know if you need any help.